Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Mastering Data Structures and Algorithm in Java. Today's data structure is queues, part 3. If you have not seen the part 1 and part 2, please go through part 1, part 2. We are not going to repeat the same for part 3. So we studied queue data structure, the definition, key operations, enqueue and dequeue. Similarly, the type of queues, simple queue, circular queue, priority queue and double-ended queues. We also learned queues position in Java interfaces or Java collections. So queue extends collection, which extends iterable. Queue is implemented by PriorityQueue and also implemented via dec by linked list and array dec. So in second part, we already saw the implementation of how we can do a custom implementation of linked list queue, and in this part we'll be seeing how we can make a custom implementation of priority queue. Okay, so queue interface implementations, there is linked list, there is priority queue, and then there is array dec. We have already seen how we can make a custom linked list queue. In this video we are going to see how we can make a custom priority queue. So we already know the operations that we can perform on priority queue and how we can use priority queue, linked list queue and array dec. In last part, in second video, we already covered the custom implementation for linked list queue. In this one, let's see for priority queue. So we'll say priority queue. Okay. So from the, I'll quickly remind everyone. So from the general perspective of the queue, there is one side is in and the other side is out. We call it FIFO, which means first in, first out, right? Now in simple queue or the linked list queue, we were making the same queue using nodes. So it'll have one element 1, 2, 3, 4 and this way. We'll call this side as front. We'll call this side as rear. Elements are added on the rear end and elements are printed from the front end. For this queue, our input would have been 4, 3, 2, 1 and we'll print it out as 4, 3, 2, 1. Okay. Now for the priority queue. So before I go into implementing our custom priority queue, let me give you a brief understanding of the underlying data structure that it uses. So priority queue actually uses heap data structure, and by default it uses min heap data structure. So we'll be covering this thoroughly in our min heap data structure video, but for the background of this video, let me quickly explain how does the min heap data structure works. Okay, so what happens in a priority queue, that it is not only can so like in case of linked list queue, it gives out the output in the same order as it was fed. So if it was fed 1, 2, 3, 4, it will give 1, 2, 3, 4. For 2, 7, 1, 9, it will give 2, 7, 1, 9. This is normal queue or the linked list queue. But in priority queue, this output will come out as, since default 1 is the highest priority, so output will be 1, 2, 7, 9. So you can define a priority based on which output should be used. So it's same as when there are multiple jobs assigned to a printer, it picks up the jobs based on the priority. Let's say the shortest job first, so whichever job is going to take less time, the printer will start printing that job, and then one by one. So in priority queue, you can insert it in any format, but the output will always be in the format of priority. Okay, so let's understand how does min heap save this value in the backend or in the background. So let's say your input is 2, 5, 1, 9. Okay, so we have 2. Let's make this much easier. Okay, so let's say we inserted 2. Now when we insert 5 will always be inserted at the next child position 5. Then it checks with 2. So we'll follow 3 methods. One is insert at leaf node, so the last place, and then heapify it. Heapify means, as per priority, always the highest priority element should be at the top of the tree, so we can directly retrieve it. So we inserted 5, we check with 2, okay, 5 is big, 2 is smaller than 5, 2 stays on top. Then we insert 1, we inserted 1 here at the bottom, then we switch it to 2, and 2 moves to 1's position. So it becomes 1, 5, 2. Then 9 is inserted, again 9 will be inserted at the root position, 9 is already smaller than 5, then okay. Now we want to print the output. So we can see that 1 is at the top, we can do the removal in O of 1. So steps would be return the root, that is this one. 1 in this case is our root. Then delete the node. Then the last leaf node, in this case 9, will get transferred to the root. So we will transfer leaf node to root and then heapify. So if I wrote it in 4 steps, but if you see it in 3 steps, it is first return, that is 1 will be printed in the output. Second, 9 goes to 1's position, so that is transferred to root. And third is heapify, so that is reheapify. So what will happen in heapify? Let's understand it here. So what will happen in heapify is, our tree looked something like this. 5, 2 is here, then 9, right? So we want to start printing them. We are doing the dequeue. So we'll get 1 from the head root, we can directly return. So 1 goes away, and in the next step the tree becomes 9, because 9 will move to top, 5, 2. Then 9 checks with 5, so 9 is bigger than 5, so it swaps. So then it becomes 5, 9, 2. And since there is nowhere else to go for the 9, this is already, there is no children below 9, so it stays here. Now when we print the next, we do the dequeue again. So we get again from the root, that is 5, so 5 gets printed out. Again the last element, that is 2, it moves to the top, so the next tree becomes 2, 9. Next time we take out from the root, 2 comes out. Since it's already heapified, 2 does not swap with 9. In the end 9 is left alone, and then 9 gets printed. Okay, so this is how min heap works. So in min heap, what it means is, the highest priority is already given to the smallest element first. If we do max heap, it would be the largest element first. Okay, so by default PriorityQueue uses min heap, but at the same time you can define the custom, let me delete all this, you can define your own custom implementation. Okay, now in this you can define how you prioritize the elements, whether it's based on which number is smaller, which number is bigger, or number of characters in a string, or anything, right? So that is what we are going to learn in today's video, how to implement a custom PriorityQueue queue. Okay, so custom PriorityQueue means a queue built on PriorityQueue data structure. Okay, so we saw, right, for queue implementation there are three classes. Linked list class we covered in the last video, PriorityQueue will cover in this video, array deck in the next video. Okay, so let's go to PriorityQueue. We'll create a new class. We'll call it PriorityQueue. Queue. Okay, now again, just like in the last video, we want to make it generic so that it will accept all the data types. So we made it generic with T. We are using the return types as generic so that any wrapper class can implement it, whether it's integer or object class, integer, string, or anything. Okay, so what do we need in this? First, let's make an element so that we can define our custom implementation as well. So we'll use private static class element, which can be of any type. Okay, now T value. What else? Let's give priority, int priority, right? We'll create a constructor element T value int priority. This dot value equals value. So this is simply a constructor, and this dot priority equals priority. Okay, I'll put in comments constructor. Okay, sorry, not here. Okay, so we got our element class that will hold the value of the data. So it could be string value, integer value, float value, or object class value, and then a priority assigned with it. So priority will be priority number. Okay, now let's make a PriorityQueue queue, right? So private class name is PriorityQueue. We'll make a PriorityQueue of element T, and we'll call it queue. Okay, so in order to make our custom PriorityQueue queue, we are using the PriorityQueue data structure only, because PriorityQueue data structure is already by default using min heap, right? So now we'll say public. We need to do, anytime when we are implementing queues, we have to do few things, that is enqueue, dequeue, and printing it out, right? So like we did last time for the linked list, we made an enqueue method, we made dequeue method, we of course went with peak, size, and is empty or not, right? So we need our enqueue method, so we'll call it priority. Now we need for PriorityQueue, we have to make, which all method do we need? Enqueue. Let me just put it in comments. dequeue, enqueue. Okay, every time. So let's make private PriorityQueue our constructor, and that'll, so here actually we can define, or let's first let me define and then tell you. So we can define our custom priority, or on the logic based on which the priority will be decided, whether the priority is based on the highest number first or the smallest number first. The priority will be decided on this. Okay, so queue equals new PriorityQueue. But so generally we always use PriorityQueue just like this, but here we are also going to define our comparator. We'll use lambdas directly. So I'll say a, b, so you can consider a, b two elements, and we are giving the priority that if a dot priority minus b dot priority. So if a's priority is bigger than b's priority, a will be returned, otherwise b will be returned, right? Okay, so now we have defined the priority as well. Now we need two methods, the enqueue and the dequeue. Let me put comments for this here. Custom comparator to compare elements by priority. Okay. Okay, now we need our enqueue method, right? Enqueue operation, add an element with a given priority, because now each element will have a priority as well. So we'll say public void enqueue t value generic, and then int priority. So we'll create element of type t, element is equal to new element, and we'll pass value and priority. Okay, so this element is nothing but the element that we have defined here. It's nothing but just like a node that we use in linked list. So similarly we are using an element, so each element will have a value and a priority. Okay, so before enqueuing we create the element and then we will add it to the priority queue. Since we are using priority queue to build our custom priority queue, we'll use the priority queue method. So we can say queue dot offer element. Okay, similarly we'll do dequeue operation, remove the element with the highest priority, right? Because as we saw in this, when we had a tree like this, 1 5 2 9, this is our most, or not most, but let me remove highest priority element, right? So we get 1 out first, then we get 2 from here, then we get 5 from here, and then finally we get 9, right? So the same thing we have defined in with our custom comparator as well, that if A's priority is higher than B's priority, return A, otherwise B, and that's how you save them in the priority queue. Okay, so let's implement the dequeue method. So say public t dequeue. Okay, what do we need? So we need to pull the element out of the queue. So we already have the element in the queue, so we'll say element t element is equal to queue dot pull. Okay, if some of you are thinking why we are not checking if the queue is empty or not, or for the null as we did for linked list, because in this one we are using a priority queue already, which is already making checks for these functionalities. So return element, but we will check that when we are doing a poll, and if the element does not exist and the original priority queue returns a null, then we should check before returning it to our custom priority queue. So we'll put a custom check on top of this one. So if element is not equal to null, we'll say element dot value, right? Otherwise we'll simply return null. Okay, that's all. What more method do we need? We need a peek method as well. So we'll add for the peek, for the is empty, and for the size as well. Okay, where are we? Okay, so we'll say peek operation, get the element with the highest priority. So by now you know that peek does not remove the element or does not dequeue the element from the queue. It only fetches the value of the element, right? So the element would still be available in the queue. So we'll say public t peek. Okay, element is equal to queue dot peek, because since we are using queue already, we are using priority queue already, it already has this methods peek, poll, and we are not defining these methods again. So for our custom peek, we're just returning the same peek, right? So we'll say return element if not equal to null, then element dot value, otherwise null. Okay, now the last method is to check if the queue is empty. So we'll say public boolean is empty and we'll return queue dot is empty. Okay, there was one more method. Okay, the size. Okay, so we do not have a size variable here, but the priority queue in underlying priority queues already has the size variable, so it can directly return us the value of the size for the queue. So we'll say get the size of the queue, public int size, return queue dot size. Now it might arise a question that if we are using a queue already to implement a priority queue, if we are using a priority queue already to implement a custom priority queue, what is the point? The point is priority queue by default has the min heap property. That means the smallest element has the highest property. But using a custom comparator, you can change the priority values. You can compare them based on values. You can compare them based on different values, whether it is based on priority or name or length in name or date of birth. All those custom checks you can make in the custom comparator. Okay, so we have all the elements. We have the size, we have the is empty, we have the main method. So let's implement. Okay, oh, we don't have the main method. Let's implement the main method. Public static void main string args. Okay, so we need priority queue, not priority queue, we need priority queue of type string. Okay, so why string? Because we saw for linked list also that we built it with the generic type, and we already tested with the integer values. For priority queue, let's go with the string as well, so that you can actually replace this with integer also, but just for fun of it, let's check for the string one. Priority queue is equal to new priority queue. Okay, now first we will enqueue elements, enqueue elements. So pqq dot enqueue will pass the value, so low priority. Okay, and we'll also give it a low priority, that is 3. Okay, then we'll have pq dot enqueue, we'll use medium priority and we'll give it the value 2. Okay, and similarly we'll put one for highest priority, pqq dot enqueue highest priority 1. So now we all know, wait, what's okay, now we all know this element has the highest priority 1, the smallest element. Then the lowest priority is for 3, or the first element, no sorry, element is low priority, priority is 3. Okay, low, medium, I'll just keep it high. Okay, let's print them and check. System dot out dot println size of the queue, so we can do priority queue dot size. Okay, that's done. Size of the queue is 3. Okay, similarly let's check the element on top. System dot out dot println peak element, so we can do priority queue dot peak. Okay, that's done. So we can see the highest priority element is coming out first, though we had added on the third value, right? So it's same as if you understand just them by 3 to 1 priority. You can understand them something like this, that okay, we wanted to insert 3, then 2, then 1. So we inserted 3 head, 2 came here, then went to root, and 3 swapped, so it became 2, 3. So 2 is at the highest priority as of now. Then we want to insert 1, so 1 will get inserted on the last position, 1, and then swap with 2 again, since 1 is smaller than 2, so it becomes 1, 3, 2. Okay, in min heap, remember, the number greater than 1 can either be on the left side or the right side. That does not matter. What matters is that the highest priority or the smallest element should always be on the top, and anytime we remove the element, we reheapify this method. So once we remove 1, 2 goes to 1's place. Okay, you'll understand it much better once we go through the min heap data structure as well. Okay, so where were we picked the element. Okay, let's dequeue elements. Okay, so system.out.println size after dequeue, or first should I size after peak would not change, or wait one second, let me dequeue the element first. Dequeue. Okay, so we'll say PQQ dot dequeue. Okay, so we are dequeuing an element. Let's see what happens. So as of now, when we dequeued, high priority element got removed, right? Let's dequeue one more time. Okay, now the highest priority element was removed, so 1 was removed, then medium 2 is removed, and now only 3 would be left. So we'll check system.out.println size of the queue after dequeue. Okay, oh, I'll capitalize this, dequeue, not capitalized, but yeah. So size after size of the queue after dequeue would be pqq dot size. Of course, it will give us the value 1, so that is 1, and in the end will also check for the empty or not. Is the queue empty? We'll say pqq dot is empty. Okay, so false, right? Because 1 is because the lowest priority element, low priority is still in the queue. Okay, now see, so this is what we have covered for the priority queue implementation, that we use the priority queue to implement our own custom priority queue where we can change the priority of the elements, right? Let's see what would happen if I move, instead of a dot priority, I do b dot priority minus a dot priority. Okay, so we have the high priority, medium priority, and now it should reverse. Okay, because now we are saving in reverse manner, so the low priority element will come out first, or the highest value element will come out first, right? I'll just revert it for now, because the same code will be available to you on GitHub as well. You'll find the link in the description. I'll run it again. Okay, right? So that's all on how we can implement our custom priority queue. In the next video, we'll check for the array deck as well. This is from the same slides from the last video, so you can take a note of these things, the differences between the linked list queue, the priority queue, and the array deck. Okay, So in the end, the summary, same queues are functional data structure. They support first in first out operation, except for the priority queue, because there you can define your own custom priority on how and on which terms the elements will be dequeued. Okay, and queue operations involve enqueue, dequeue, and peek. So that's all from oh, I should have changed it. This is not part 2, this is part 3 actually, my bad, sorry. So that's all from today's video, everyone. If you have any questions or require any clarity anywhere, please let me know in the comment section. In the end, please like, share, and subscribe. Thank you.